The question is a roller of 40 diameter rolls over a horizontal table without slipping for one complete rotation. Draw the path traced by the point P on the circumference of the circle. Also draw a tangent and a normal at any point on the curve. This is the question. Okay. So in the question itself, I have mentioned that it is a in the question they have not mentioned anything about type of curve. So here there is a roller object. The roller diameter is 40 mm. Rolls over a horizontal table without slipping for one complete rotation. So if there is a statement like this, there is a circular object or roller rolls along a straight line without slipping for one complete rotation, then you have to identify that this is a cycloid problem. Then after tracing, when the roller rolls for one complete rotation without slipping for one complete rotations, what we have to do? We have to trace a point on the circumference of the circle for one complete rotations. If you trace that, you will be getting a curve. That curve is called a cycloidal curve. That is what they are asking. After drawing that cycloidal curve, we have to go for a normal line and tangent line. We have to draw normal line and tangent line at any point on the curve. So here, given a cycloid, so first what you have to do, you have to write on the given data and write the name of cycloid. Here the roller diameter that is represented by small letter d, that is 40 mm. Then you have to do the statement. That is when the circle rolls for one complete rotation, it will cover a distance of circumference of the circle. So we know that the circumference of the circle is the L equal to pi d, length L equal to pi d. So here the diameter is 40 mm. The pi value of pi is 3.14. It becomes the product is 125.6 mm. You can take it as around of 126 mm. So when the circle rolls when the 40 mm diameter roller rolls for one complete rotation without slipping in a straight line manner, it cover a distance equal to 126 mm. Okay, so now we have calculated the circumference. The next we are going for the drawings. So here first draw the circle based on the given data. So here the roller diameter is 40 mm. So in your compass you have to take a 20 mm as radius. Then rotate the compass. Then you will be getting the 40 mm diameter circle or 20 mm radius circle. Then divide the circle into 12 equal parts. So a circle equal to 360 degree. So if you divide the circle into 12 equal parts, 360 divided by 12 equal to 30 degree. So by taking 30-degree marking on the circle, you have to divide the circle into 12 equal parts. Then give the numbering in anti-clockwise directions. That is, when the circle rolls, we are assuming that the circle is going to roll in clockwise directions. If it rolls, which part will have contact on the ground? That's where you have to give the numbering as what. So here first contact is this one, this part. That is division 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then after drawing circle and divisional points, we have given numbering. Then you have to draw horizontal line from all the divisional points. From all the divisional points. So first from there is a roller which is initially having contact on the ground. You assume the roller is having contact on the ground. The point which is having ground contact on the ground, they meet as P. This is the point P, right? So from here to this line, from the center, there is a point P 12. To this line perpendicularly, you have to draw a line for 125.6 mm. Then at this end, you draw one vertical line. Then from all the divisional points, you draw horizontal line. Okay. The next, when the circle rolls along a straight line for one complete rotation, the circle radius not going to change. But when the circle rolls, we are going to trace a point on the circumference of the circle. So when the circle rolls, a radius remains same, but the center point keep on changing. When the circle is here, this is the center point. Suppose if the circle is shifted to somewhere, this may be the center point, new. This is third center point, fourth center point, fifth center point. So we have to find out the new center points. So for that, what you have to do means you have to divide this baseline into 12 equal parts. So 125.6 divided by 12, you will get some value. It's maybe 11 mm or 12 mm. So here it comes as 128.6 divided by 12 equal to 10.466 mm. We can roundly you can take it as 10.5 mm. So by taking 10.5 mm as distance, you have to do marking on the baseline. Give the numbering as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then from there you have to draw vertical line until meeting the circle center line. Then give the name as this is C, this is C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. When the circle rolls, initially we have marked a point on the circumference of the circle, which is having contact on the ground, named as P. When the circle is here, this is the point, marked point. Suppose the circle shifted to here, new center point, C1. At that time, the point may be shifted to here, then maybe here, here, here. This may be the path. How to track that? How to track that means in your compass you have to take the measurement of radius of the circle. Then C1 on the center line we have marked as C1. This is center point. Make a arc on the first horizontal line. We have given numbering for the horizontal line 1, 2, 3, right? So you have to do marking. We have to do arc on the first horizontal line by taking C1 as center point. Name it as P1, first tracking point. Similarly, for the same radius, because the radius of the circle not going to change when it rolls. So for the same radius, C2 center point, make arc on the second horizontal line, make it as P2. Name it as P2. Similarly, C3 center point, make arc on the third horizontal line, C4 center point, make arc on the fourth horizontal line, C5 center point, make arc on the fifth horizontal line, similarly sixth horizontal line, seventh, eighth, ninth, 10th, 11th, 12th. Finally, the 12th arc will come here. You have to give the name to all the arc P1, P2, P3 until P12. Then after that, from P, you have to draw a curve passing through all the arc. Then you will be getting smooth curve. That curve is called cycloidal curves. Then you have to give the name to the curve as cycloid. After drawing the cycloid, you have to draw normal tangent. So how to draw normal tangent for the cycloidal curve means you take the circle radius in your compass. On the cycloidal curve, you mark a point somewhere. Name it as M. From M as center point, make a arc on the center line. Then from there you draw vertical line until meeting the baseline, name it as N. From N, draw a line passing through M and extend the line, name it as N dash. This is the normal line. To this normal line perpendicularly, you have to draw another line passing through M, name it as TT dash. So this is your tangent line. This one is a normal line. After that, you have to give explanation to all the notations. And at the bottom right hand side, you have to write all dimensions are name.